In both problems 5 and 6, we want to find the x-intercept and the y-intercept in 5 for this equation and in 6 for this equation. Let's try number 5 here. So in 5, we've got this equation, x plus 5y equals 0. Now let's set up a little table. We'll get the intercepts by choosing 0 for x and then 0 for y. So if we choose 0 for x, put 0 in here, what do you get? 5 times 0 is 0. So y is 0. Well, then it makes no sense to do this, right? Because if that's 0, this is 0. So what's the x-intercept and the y-intercept? The x-intercept is 0, 0, as well as the y-intercept. So this line, if we were to graph it, goes right through the origin. And in number 6, here's our equation. Let's write that equation. It's going to be y equals 5x plus 11. Let's set up a table where we'll add x equals 0. That'll give us the y-intercept. So let's put 0 right back into here for x. So doing so will give us 5 times 0 plus 11, which is 11. So here's an ordered pair, 0 and 11. And that's the y-intercept. And then when y is equal to 0, I'm going to put stars here. Those are the ones I'm choosing. When y is equal to 0, put 0 back in here. So that's going to give us, well, we better do this one here. This is going to give us 0 equals 5x plus 11. Let's subtract 11, right? We'll subtract that 11. So we will get 0 minus 11 is negative 11 equals 5x. And when we divide by 5, we'll get x is negative 11 fifths. So that's going to give us this ordered pair, negative 11 fifths and 5. All right, so let's just summarize what we have here. The x-intercept and the y-intercept. Now the x-intercept is where y is equal to 0, right? Because you're not above or below. So that's what we found here. We found negative 11 over fifths and 0. In fact, I should probably fix that one right there. That is negative 11 fifths and 0. And then the y-intercept, this is where the line intercepts the y-axis. And if it intercepts the y-axis, you're not left, you're not right of the origin. So x is 0, and that's what we got for this one here. So that's the 0 and 11. There we go. We got both of those.